Well, we'd get 12r plus 3k for the numerator and 12r minus 3k for the denominator. Nice algebraic skills if you got these two correct. If this gave you some trouble, that's totally okay. Let's see how we can distribute this kr to each of these terms. If we distribute kr to each of these terms, we can see that we'll have this complex fraction. Now we need to simplify the multiplication for each term. Some students are really great at doing it in their head from this step, though sometimes I think it's better to show this so you can really see which factors are canceling in a numerator and a denominator. For example, we can see that k divided by k equals 1 here, r divided by r equals 1 here, and we repeat that process in our denominator. So we're left with 12 times r, or 12r, plus 3 times k, or 3k. For the denominator, we're left with 12 times r minus 3 times k. Then we should always ask ourselves if we can simplify our answer. I've rewritten it here so we can see it better. We don't want to make the mistake that this fraction equals 1. We have addition here and subtraction here. Also, these are not opposite polynomials, so this fraction doesn't reduce to -1. The coefficient of r is positive 12 here and positive 12 here. But we can see that this term and this term share a common factor of 3. The same is true here. We factor a positive 3 from the numerator and from the denominator. This leaves us with 4r plus k divided by the quantity 4r minus k, our final fraction. After multiplying by the LCD over the LCD, we really want to check if we can simplify. Sometimes this isn't always our final answer.